Welcome to the deep dive. Today we're going to unravel something pretty fascinating. The history of astronomy and astrology, how they started together, and why they're so different now.
That's right. And if you're listening, you want to get up to speed quickly, understand that connection, or maybe lack of connection today.
Exactly. We've got some great sources that dig into this long history, right back to the beginning.
Yeah, our goal here is really to trace those shared roots and figure out, where the paths diverged, how one became this rigorous science we know today, and the other, well, something else.
Okay, so let's dive in way back. Our sources talk about evidence, like really ancient evidence, markings on bones, cave walls, 25,000 years ago.
Yeah, it's pretty incredible. And what seems really significant is that these markings often track the moon, the lunar cycles.
So not just random doodles, they were actually keeping track.
It looks that way. It suggests a real practical need. Tracking time, seasons, maybe animal migrations or river levels, things vital for survival and organizing, early communities.
Right, finding some order in the heavens.
Exactly. And that basic observation, that was the seed for both fields, really.
And then as people started farming, that need must have gotten even stronger, linking sky patterns to agriculture.
Absolutely. You see constellations becoming markers. When that group of stars rises, it's time to plant or time to harvest. The sky becomes this giant agricultural calendar.
So one source defines early astrology kind of broadly as just the search for meaning in the sky. Does that fit here?
Perfectly. In those very early stages, looking up was searching for meaning. And it was completely tied to observing patterns, what we now call basic astronomy. The line was blurred or maybe just non-existent.
Okay, moving forward a bit, Mesopotamia. This is often called the cradle of civilization, and we find this amazing figure in Hedwana around, 2300 BCE?
Yeah, roughly. And she's fascinating. Considered the first known poet, but she was also deeply involved in tracking the moon. She wrote poems about the moon.
Wow, so observation and artistic or spiritual interpretation are still totally linked.
Right. It shows that unity perfectly.
Yeah.
She wasn't just noting its position, she was engaging with it.
Yeah.
And after her time, the Babylonians, they really took the mathematical side further.
Right, they developed serious math for this, didn't they? I read they figured out the Saros cycle for predicting eclipses.
They did, which is remarkable. It let them predict lunar eclipses years ahead.
Yeah.
That needs really careful record keeping and sophisticated math.
In their math system, the base 60 thing.
Sexagesimals, yeah. We still use it. 60 seconds in a minute, 60 minutes in an hour, 360 degrees in a circle. That legacy comes directly from Babylonian astronomy.
Incredible. But here's the key point, right? They use these same advanced math skills for what we'd call astronomy and for astrological predictions.
Exactly. Predicting an eclipse was scientifically useful, but it was also seen as a major omen. The two purposes were served by the same observations and calculations, still intertwined.
Okay, so that takes us to the Greeks and the Hellenistic period. Things start to shift here, towards a separation.
That's a good way to put it. You start seeing Greek thinkers looking for rational physical explanations, less about omens, more about how it works.
Like Aristarchus of Samos, proposing the sun was the center, not the earth. That was revolutionary for the time.
Hugely revolutionary, and mostly ignored for centuries, but it shows that mindset shift. Then there's Hipparchus, a giant figure. He discovered precession, the slow wobble of Earth's axis.
And measured the moon's size and distance, invented the astrolabe, made a star catalog. That sounds much more like science as we know it.
It absolutely does. It's about measurement, calculation, building physical models.
And what about that Antikythera mechanism, that ancient Greek device?
Oh, that thing is just amazing. Basically an analog computer from 150 to 80 BC, designed purely to calculate where the sun, moon, and planets would be.
So pure mechanics, no interpretation needed, just calculation.
Precisely. It's a stunning piece of technology that really points towards, purely astronomical way of thinking. But the dominant model was still Ptolemy's geocentric system, Earth at the center. And while astronomy eventually moved past it, that Earth-centered view actually stuck around in astrology for much, much longer. It fit that framework better, perhaps.
Right, so astronomy starts building its own toolkit, its own models, even if some early ones were wrong, while astrology kind of held on to the older cosmological picture. Makes sense.
Yeah.
Okay, let's jump to the Islamic Golden Age. Sources say this was a period of major flourishing for astronomy.
A huge flourishing, yes. Starting around the 9th century, you see the establishment of the first proper astronomical observatories, dedicated places for observation.
That's a big deal, and they made some key discoveries.
Absolutely. Abd ar-Rahman al-Sufi gave the first description of the Andromeda Galaxy back in 964, calling it a little cloud. And Ali ibn Ridwan observed the SN 1006 supernova.
Which was supposedly the brightest stellar event humans have ever recorded.
Exactly. Incredible stuff. And scholars like al-Biruni, they weren't just accepting Greek ideas wholesale. He noted issues with Ptolemy's model, like the sun's apogee, its farthest point moving. They were refining things based on observation.
Pushing the science forward.
Definitely. And, a lot of the star names we use today, Aldebaran, Betelgeuse, Vega, they're Arabic names. That's a lasting contribution from that era.
So they really advanced the observational and mathematical side. Now, medieval Europe and the Renaissance, this seems to be where the split becomes, well, definitive.
I think that's fair to say. Interestingly, the church in Europe actually supported astronomy quite a bit in the Middle Ages.
What was that?
Partly practical. They needed accurate astronomy to calculate the date of Easter, which depends on the moon.
Ah, right. And there were European astronomers making contributions too.
Oh, yes. People like Richard of Wallingford built incredibly complex astronomical clocks. And thinkers like Khwarizmi and Buridan were discussing, even back then, the possibility that the Earth rotated. So the thinking continued.
But then came the big names, right? The ones who really changed everything.
Exactly. Copernicus, putting the sun back in the center with his heliocentric model. Then Galileo, using the telescope to see things nobody had seen before, moons of Jupiter, phases of Venus.
Stuff that didn't fit the old Earth-centered model.
Not at all. And Kepler, figuring out the laws of how planets move those elliptical orbits. But the real clincher was Newton.
Isaac Newton. Gravity.
Universal gravitation. He provided the physical mechanism. Why do planets orbit the sun? Gravity. Why do moons orbit planets? Gravity. Suddenly you had a physics-based explanation for the whole system.
And that made the old astrological ideas about celestial influence seem, well, unnecessary or just wrong.
Fundamentally incompatible, really. Once you understand the celestial mechanics through physics, the idea that planetary positions directly influence individual human lives just doesn't fit within that scientific framework. That's the definitive split.
So that brings us pretty much to modern astronomy. How do our sources define it now?
As a natural science, plain and simple. It uses math, physics, chemistry to study everything out there. Planets, stars, galaxies, nebulae, black holes, the universe itself.
Focusing on their physical nature, their origins, how they evolve.
Right. It's about understanding the what and the how based on evidence and physical laws.
And astrology, by contrast.
It's defined now as a belief system, or maybe a pseudoscience, claiming a correlation between celestial positions and, human personality or events on Earth. The two are seen as entirely separate domains today.
Even the word astronomy, law of the stars, in Greek, hints at that original quest for order, which science eventually took over.
Precisely. And today, you'll often hear astronomy and astrophysics used almost interchangeably. That really underscores how central physics is to the modern field.
And the tools are incredible now. We're not just looking with a visible light.
Not at all. We use the whole electromagnetic spectrum, radio telescopes, infrared, ultraviolet, X-ray, gamma ray. Each window shows us different things, different processes happening out there.
It's like having multiple kinds of eyes on the universe.
Great analogy. And then there are the even newer fields, not based on light at all. Neutrino astronomy, cosmic ray studies, and gravitational wave astronomy.
LIGO. Detecting those ripples in space-time back in 2015, that felt huge.
It was monumental. It literally gave us a new sense to perceive the universe, to hear events like black holes merging. It confirmed Einstein's predictions and opened up completely new avenues.
And beyond just looking, there's theoretical astronomy too, building models.
Yes, developing the big picture ideas. The Big Bang Theory, models of stellar evolution, galaxy formation, and trying to tackle the huge mysteries like dark matter and dark energy. What is most of the universe made of? We still don't really know.
It branches out so much now, too. Things like astrochemistry, astrobiology.
Right. Studying molecules in space, searching for life or the conditions for it elsewhere. Even archaeoastronomy, which circles back a bit, studying how ancient cultures understood and used the sky. It shows the breadth of the science.
Something else mentioned is the role of amateurs. Astronomy is one field where non-professionals still make real contributions.
It really is quite unique in that way. Amateurs discover comets, they track asteroids, they monitor variable stars, observe supernovae. Their observations, especially for transient events or long-term monitoring, are incredibly valuable.
That's fantastic. But even with all this progress, professionals and amateurs working together, There are still big questions, right? Huge unknowns.
Oh, absolutely. Massive ones. We mentioned dark matter and dark energy. That's maybe the biggest mystery. What's the ultimate fate of the universe? Why is there so much less lithium than the Big Bang predicts? How typical is our own solar system?
How do stars form with the range of masses they have? How did the first galaxies and supermassive black holes get started so early?
Exactly. Deep, fundamental questions remain. And, of course, the ultimate one for many.
Are we alone?
Is there other life out there? The search for extraterrestrial intelligence, the Fermi paradox, why haven't we heard from anyone if life is common? These continue to drive a lot of scientific thought and, frankly, public fascination.
So, wrapping this up, it's been quite a journey from looking up and seeing maybe gods or omens or just a calendar.
To seeing physics, chemistry, gravity, space-time, galaxies forming, maybe even the potential for life elsewhere.
The core takeaway really is understanding that history. They started together, this observation and interpretation. But astronomy took the path of the scientific method, testing, measuring, building physical explanations.
While astrology maintained its focus on interpretation and finding correlations, but without that basis in physics or testable mechanisms from a scientific view. They're fundamentally different approaches now.
Understanding that split, why it happened thanks to figures like Newton, that's the real aha moment, I think. So a final thought for you, our listener, just think about how our relationship with the night sky has changed. That same canopy of stars inspired awe, maybe fear, practical calendars, complex myths. And now it drives this incredible scientific quest to understand the universe at its deepest levels, from omens to physics. It's quite a transformation. We hope you keep exploring.